Hello and welcome to this Omron Tech Talk. During this video we'll see how to set up and achieve communications from an NJ or NX machine controller to a KM-N2 power monitor. One application of this is to add power consumption monitor features to an NJ or NX that controls the main machine functions. In further videos we'll see different methods to collect this power data from the perspective of the machine end user. The KM-N2 features 2-wire RS485 serial communications and can connect to an NX1 P2 controller via an NX1 SIF11 or SIF12 option board, or to an NX SIF105 slice on an EtherCAT NX bus coupler to any NJ or NX controller. The SIF105 can also be mounted directly to any NX1 P2 or NX1 controller. The KM-N2, or KM-N2 FLK to give its full part number, can connect up to 4 generic 1A or 5A secondary CTs as 4 independent power circuits of single-phase 2-wire or 1 circuit of 3-phase 4-wire. It supports the Modbus RTU protocol over 2-wire RS485, and up to 99 KM-N2 units can be connected in a single daisy chain. Now let's look at the controller. For this example, I'm using an NX1 P2 controller with an NX1W SIF11 communications option board. First, on the back of the SIF11, set the dip switches as shown to set it for 2-wire comms with terminating resistor. To the top terminal block of the KM-N2, set the Modbus slave address with the rotary switches. I will use an address of 1 in this example. Wire the RS485 cable, positive to positive and negative to negative, and make the link as shown to enable terminating resistor. To the bottom terminal block, wire the voltage monitoring and CT terminals as shown, this example for 3-phase 4-wire with 3 CTs. And this example for single-phase 2-wire with up to 4 CTs for 4 separate monitoring circuits. For this video I am using single-phase 240 volt and a single CT wired as shown. Don't forget to install and wire the CTs the right way round. K or S1 must be on the power side and L or S2 must be on the load side of the live wire. Setup of the KM-N2 is straightforward, and at factory default I am setting up 1 circuit of single phase 240 volt with a single current transformer. Here's the specifications for the current transformer: 100 amps primary and 5 amps secondary. Press and hold the mode button for at least 1 second. Enter the password. Default is 1. Now we are in setting mode. First shown are the phase and wire type settings for circuit A. Press enter, make the required selection and press enter again. Press the down arrow key, the Modbus slave address is shown. Press down again to show the CT secondary side current, default is 5 amps. Press down again to show the CT primary side current. Press enter, make the change to 100 amps and then enter again. To finish settings, press and hold the mode key for at least 1 second. The settings are saved and the KM-N2 reboots. I didn't need to make any communication settings since I will use the default settings of 9600 BPS, 8 data bits, 1 stop bit and even parity. Connections complete and the KM-N2 set up, let's turn our attention to the NX1 P2. In SYSMAC Studio I have created a new project for the NX1 P2 I'm using. First step is to add in the SIF11 option board. We do that here. I mounted it into slot number 1. We tell the option board it's running in Modbus RTU master, 9600 BPS, 8 data bit, even parity and 1 stop bit. Next I shall bring in a library in which I have a function block to read data from the KM-N2. Click on plus, it's this library here. So within this library I have a function block called KM-N2 data read. These are the input and output parameters. Key is this variable here, RCV-DAT. This is of this user-defined data type, which is included inside the library. This one here. So within this data type, we have all the readings from the KM-N2. So the voltages, the currents, power factor, frequency, active power, reactive power, phase-to-phase voltage, and so on. We'll see that in action shortly. Now we can start programming. So first off, I'll put in a contact. And then we'll bring in the function block, which is listed here in the toolbox. Give the function block an instance name. And fill in the inputs. First is this one called port details. This tells the function block about the SYF11 that we're using. We'll fill in some settings for this in a while. Next is the Modbus slave address for the KM-N2. We set the KM-N2 to Modbus slave 1. Next we can reset the active energy values within the KM-N2. So we'll create a variable for that and we'll see that in action. And then finally the variable into which we want to read the KM-N2 readings. And then the outputs. We have an output to tell us that communications is active. We have an output to tell us there's a communication error. And we have a flag to tell us if we execute a reset, this output here tells us the reset is complete. Okay, so the last step is to fill in this variable here. So I'll insert a rung above. We'll execute it on a first scan flag. I'll drop in a block of structured text. And we can fill in the details. So first, port details dot device type, which is device type, and then hash its option board. Next, we tell it where the option board is. So to do that, we have to create a node location variable for the option board. And we do this in the IO map. We show the option board, right click over it, and select this display node location port option. Expand that, and we can see it here. So all we have to do is give a variable name. There's a variable name there. Back to the program, we can just fill that in now. So this tells the function block which communications option we're using. Then we tell it the port number. Some option boards have more than one port, so we have to give it a number, even though there's only one port on the SYF11. And then finally, we'll turn on the active flag. So this is picked up in this contact here. Okay, we can go online. Oh, once I've told it how to communicate. Yes, it's there. So online with the controller. And then we can send the program and settings down to the NX1P2. Okay, and put the controller into run mode. Okay, so we can see we have communications active, and we can look at the KM-N2 readings on this variable here. If I open a watch window, and we can see them there. I just undock this window for a moment, and we can see all the values. So we have the voltage, current, power factor, frequency, active power, reactive power, and then the active energy and reactive energy. There are two sets of values. There's these, which are non-resettable, so you can't reset these, whereas these ones here you can. So that's showing the current watt hours, reactive energy, and so on. So if I move this over, so if I turn on this reset flag, we'll see all these resettable values go to 0. There, they've gone to 0. We have a reset done's gone to true to tell us the reset's complete, and we can turn it off again. Now the KM-N2 power readings are in a variable in the NX1P2, we can show them on an HMI or make them available to be data logged. In the next videos we'll see various ways of how to data log these power readings. A note about setting up the NX CIF105, which is a little different to the NX1W SYF11. In this example I have an NX102 CPU with an NX CIF105 mounted next to it. In the unit settings we need to specify the baud rate, we must specify 2-wire, data bits, parity, stop bit, and finally for Modbus RTU with this SYF105 you must set the number of characters to determine the end setting to 35. This is because the Modbus specification states that in RTU mode messages start with a silent interval of at least 3.5 character times. This is handled automatically for the NX1W SYF11 when you select Modbus RTU mode, but for the NX CIF105 you must set this explicitly. And as with the NX1W SYF11, set the node location port variable in the I/O map. So we right click over the SYF105, select the display node location port option, and create a device variable. You can ignore all the other port variables shown. Finally, in the program, the port details settings are a little bit different. So for the NX1W SYF11, we specified device type as device option board, whereas with the SYF105, device type becomes device NX unit. And to put the port location variable, instead of OPT board for the SYF11, we change that to NX unit. So if I type in the name of our port location variable and build, we're complete. I hope you found that useful. Thank you for watching.